Thanks for the nice words. I hope everybody can hear me. So everybody in the room now already knows that I've been doing Lisp for quite a long time. Actually, I'm not doing Lisp development all the time. So I'm also doing project management and software architecture and requirements engineering, whatever comes up in your normal software development lifecycle, more or less. And today I'm going to talk a little bit about dependency management in Clojure, and doing that mostly from an architectural point of view and discuss some of the benefits and downsides of various applications. And one point that I would like to also stress is that Stefan mentioned Complang Lisp, and as Hans pointed out, the Common Lisp community is quite fragmented and also not always friendly. And I think that the Clojure community is very friendly and very open-minded. And I think that's one of the things that the community can really be proud of and should strive to keep that way. So, what is this talk about? This is not going to be about managing dependencies at build time, but more about how you manage dependencies within your running Clojure application. So, and if that picture on the left gives you an impression that this might at times be some sort of a painful process or not always be pleasant, that's because that's typically the way it is when we're dealing with dependencies. But more seriously, this is more about how we make dependencies available, and that goes especially in the Java community, mostly under the terms of dependency injection. Okay, so as developers, dependencies are really an everyday topic for everybody in each and every language, I think. And we often feel like Indiana Jones tracing a maze of dependencies and taking turns on each and every step until we finally find the crucial piece of code what we were hunting for, which is this treasure box in green here below. And of course, the daily what we experience daily is really that the more entangled our code becomes, the more difficult it is, the more we have to hunt, and the more difficult it becomes to change the code, right? So in this silly example, in this little diagram here, we have several boxes, basically several pieces of code which depend on this piece of code here below. And we now have if want to change basically what this piece of code here needs in terms of that dependency, we need to be very careful that we're not breaking assumptions that these two pieces of code here have, right? So, and one thing that we also need to think about, need to be aware about when we're designing our programs is the architecture that we have. So this little piece of code, or this diagram here, shows something where we typically have abstract processes on the top, and we have quite concrete functions doing work here below. So typical three-layer architecture, this might be more like UI stuff, this might be databases, whatever. And we need to think about basically, okay, what kinds of dependencies do we want to make visible basically in the various layers, right? So we don't want to have any sort of idea in this function or in this box above here that there's something below here, right? So we don't want to do that. Okay. So there's another aspect to the discussion that I think is rather relevant, and that's the notion of explicit versus implicit. So as developers, we typically we don't like surprises. We don't like to be surprised by what we find in our code. So we strive for control. And that's often, basically, it seems to be better for us that we know about something. We might not know about the details, but we know there is something that I can look up, and that's actually here the area of known unknowns. And what's really bad is often when something comes back to haunt you, which you didn't even know it existed, but it's somewhere hidden in the code and comes back to bite you, right? So what can we take away from that? Is it true that everything that is explicit cannot surprise us and hence explicit is always better? So that's obviously not true, right? Because if we take that to the extreme, then we would basically, all the things that we're using in a function, we would have to hand over as parameters to the function. And that's something that we don't want to do, right? So for instance, all the names of Clojure core, the Clojure core language, are available without programmers having to import that, right? And also, when we write our own code, we often want to hide details, the details that are better left unspoken, right? We want to hide them in a corner and be able to change that without affecting callers, right? Without having other people have to change their code. But of course, we want that relevant information is readily available, right? And that's exactly the point, again, where architectural boundaries and decisions should be obvious in our code. So, enough theory, let's look at some simple-minded and quite silly code, right? So don't think really about what is shown here in detail. All that we're going to look at is actually the use of some functions and the use of the imports, basically, up here. So we have some sort of like a UI, we have some sort of like a core layer, which is silly simulation of a music player, and we have some I/O device, which is in this case here a speaker. So we have multiple dependencies, right? So the UI layer basically imports this core layer directly because it actually has a call to play, right? And that implies that we have to make available basically this the namespace. We have to require that. Again, also the simple player with this play function calling a Blair function here, which comes from the speaker module, which is defined below, right? And I'm going to use this silly example all over the place now. So if you get bored by that silly example, it's because I would like to focus on simple things here. Okay, obviously in the reality, our code is seldom that simple-minded, right? So even in this silly example here, we might want to have different output devices like headphones or Bluetooth streaming devices, right? And the question then becomes, how can we soften the dependency on the speaker module? And the first tool that we typically can use as Clojure programmers is higher order functions. We basically just take two arguments here, which basically will bias directly that now the player module doesn't have to know about the speaker module anymore, right? So we can get rid of that. Also, we make now explicit here in this play function that we're expecting something that needs to be handed over by the caller, which is the function what we're going to call down below here, right? And similar for this other one here. But there are also some things that are still rather implicit, right? So basically, this argument here will take anything, and we just had a great talk by Michael Schauer regarding types. So there is no check going on at compile time, basically, which says that the code that will actually finally do the calling here, so this speaker Blair has actually the same signature than that this function here in play is actually using, right? So nobody's guaranteeing that speaker Blair actually will take just a single argument, right? And doesn't expect, let's say, 3 arguments. What this also shows is now that now the play module no longer relies on the speaker module, but instead we've shifted the problem to this module higher up in the chain, right? So now this UI layer somehow has to know about the speaker modules, etc., and because it needs to hand over this argument. And that's probably something that we don't want to have from an architecture point of view. So we can play a little game on that and close over dependencies. So what this implies here is that we can use factory functions like that, make play function, which just expects these 2 function arguments and returns a function closing over these arguments, and we'll call this. So, and what's important here in this approach is that the return function will only take business arguments as parameters. So the dependencies are already there, right? So then you can set up sort of like these configurations, basically, where you're defining using this factory function, speaker play, headphone play, stream play, etc. Or you can also have some sort of a selection function interactively. And then finally, this play function gets called. This function here, this play pressed, doesn't have to care about the dependencies at all, right? So now what we've gained is that we've decoupled the configuration of the dependencies from the usage during the business logic. Okay, a related pattern that we can use is using the so-called service locator pattern, which in Clojure basically boils down to just using maps and making usage of the fact that we can handle functions as first-class objects. We can define a map basically here, services, for no particular good reason, it's here defined as dynamic. And then we can define local lookup functions like this player function here again, here within the player module, which basically uses this map to check which function is actually configured and then basically put out the sound. So again, the result is that the play function now doesn't have to deal with this configuration at all. And again, basically all the configuration, all the dependencies are basically set up here in this services map. The point here is that we now here only have the dependency in play again on these methods here. And we also gain that the signature of these local lookup functions are at least the same here in the play function, right? So that's quite obvious, quite explicitly naming the signature of the functions that we're expecting. But of course, the real thing is happening at runtime. So whether, again, this player function will take just a single argument, we will only learn about that at runtime. So of course, we can play, that's a little bit tedious, right? So if you think about that you have to write all these intermediate lookup functions, that's quite tedious. And what you can do, and some people have done that, me included, is we can use macros surrounding that to ease that pain. So this is a Simpleminded library, basically consisting of two macros that I wrote. That's basically defining now here a signature of a function in Clojure terms, so not typed, which is just looking like your normal function definition, and then you can have an implementation just as well. And if you take a close look, you see that this implementation now depends exactly on this signature definition over here. So it's really the inversion of control which is reflected in this setup here now. And again, of course, the player also only depends on the signature definition here, not on the implementation. And the same service locator pattern that we just saw will apply basically and inject the function at runtime. And if you don't like that because it's hiding too much behind macros, there's also a similar library called clojureD, which makes the dependency resolution at runtime much more obvious also in the compile time in the code. So obviously, Clojure already provides another great tool for disentangling dependencies and better protocols. So protocols are basically abstract specifications that group functions which have high cohesion. And as you can see in this silly example here, is that protocols always go along with types. So here we now have a speaker record which extends the output device protocol defined above, and that basically provides the implementation. And the type is really relevant here because basically protocols dispatch on type. So you can see here that there's not really required additional argument. And if you take a look at the usage, you'll see now that the play function expects now an output device, which has to be an instance of a speaker record, for instance. But what we've gained here, again, is that the player module doesn't have to depend on the speaker record. It doesn't have to depend on the module containing the speaker record. The player module itself is fine with just having to import the output device. And summarizing basically what protocols provide us, again, is inversion of control. The caller only depends on the abstraction at compile time. And the implementation in terms of the record will depend on the protocol also only at compile time, also at runtime. And we saw that the caller has to provide an instance of a type implementing the protocol at runtime. What we also saw is that the signatures of the functions are quite explicitly declared in the protocols. So it's quite clear that protocols are the standard way in Clojure to decouple dependencies. And that also feels very natural, especially when you're looking at records which provide also a way to hold state, right? Which is more or less a way of saying it feels like object-oriented programming again, right? And that's why not all people like that. There's something that's on the announcement I just saw that I would also say something about multi-methods, and I will do that. Basically, multi-methods can be used to also provide dispatch, basically, just like we saw here with types, but basically, if all you need is dispatch, is actually decoupling of dependencies, multi-methods are really over-engineering in the wrong way to go. So we'll not go into that. Instead, I will concentrate again a little bit more about the elephant in the room, namely how going to deal with stateful dependencies. So going back a little bit to a little bit theory, domain-driven design makes a distinction between domain entities and services. There are lots of other concepts that are relevant in domain-driven design, but that's not relevant here. So in object-oriented programming, services are implemented by objects, right? It's quite simple. And object-oriented programming revolves around managing state locally within the object. Whereas in functional programs, services are implemented by functions, and we strive mostly for using pure functions which don't have any side effects. So stateful functions sound sorts of contradictory, right? So what are we going to do with that state, right, that we depend upon? But still, state management is still important, right? We still have to deal a lot with states. And we saw one way to do that with protocols already. But it makes a lot of sense to actually think a little bit about what is this state actually what we're talking about here, right? So the state looks like data, but it most of the time isn't really your normal data, right? So we're not talking about business data. We're not talking about domain entities. We're not talking about financial records or anything like that. So typically, we're talking about resources, right? So we're talking about things like connections. We're talking about things like channels, right? So email services, whatever, right? So that are resources more. And resource management and applications is really quite critical often, right? Because either you have to view, because you're getting more requests when you can open up connections to your database, for instance, right? Or because you could open up too many resources and then your system resources will go down, right? So managing stateful dependencies is quite often resource management. There are, again, two quite obvious ways to deal with that. And one is, again, using closures, like we closed over functions. You can close over states as well. I'm not going to do that, to go into that, because we've discussed that already. And the other one is actually using dynamic variables again. And that's actually quite common pattern in with-style macros. And one thing that I would like to point out here is that these sorts of dependencies are very implicit, right? So if you're using sort of like a with database connection or with connection thing, often you don't really have a way to access this connection, this dynamic variable at all, right? You can't change it, for instance, right? And there are lots of other good reasons not to really go there. And there's a great post by Stuart Sierra on the perils of dynamic scope, which also makes a lot of references to Common Lisp, which discusses this in detail. So I'm going to skip that part in the middle here. And instead, I'm going to discuss the library that Stuart came up with, which is Component. I think we saw that earlier a little bit, which is a library which also quite a small library aimed for explicit management of complex dependencies, and specifically for components which actually need a life cycle, right? Which need to explicitly be started and which also can be shut down at some time. And what component does or allows you to do is that it creates a graph of your dependencies, it builds it up, all the components are created at runtime, at start time, basically, and all the dependencies are injected, right? So you have a controlled place in time where all your dependencies are resolved, and you can assume that everything that you need is really available for your application. One thing that is also worth pointing out is that components are really elements that make up an application. So you're not supposed to use component in your library because the application might have a different idea of how you would like to manage state, right? So if you think about state again in terms of the resource that I discussed earlier, that makes a lot of sense, right? It's really up to it's a responsibility of the application to make a decision how you would like to manage the lifecycle of your resources. So how does that look like? That looks, again, a lot like a protocol record setup. So you have here, let's say now the blue streaming device, which is the output device. I omitted this thing here. The more relevant part here is the start and stop function. You have here a simple argument, which is not your dependencies. The dependency is actually over here. So it's the connection thing over here. And components will take care that everything is available, is readily available when the start function is going to be called when the system starts up. And how does component do that? You can see here now a player system function where basically a system map is constructed. You have multiple elements here. For instance, the output device making use of a connection element, which is exactly defined above here. And then you have here the player component, which depends on the output device. And when this map is generated and you start the system, basically everything will be up for use. So what we just saw is that basically when you have these sorts of components, you often end up with multiple components depending on each other, and all have to be components. So you have some code piece A, which depends on a managed state. That's your component A. Now you have another function B that wants to call function A, that then again has now to have a component, has basically a dependency on a component A, so it also needs to become a component, right? So you heard you like components, so we put some components in your components. That's another slide missing here. That's this one. Dependencies of components can be inspected and changed at runtime. There's a full buy-in, basically, that comes along with component, which often leads to code, which is basically where everything, all the functionality is managed with protocols and records. And you don't have to go that way, right? Component doesn't mandate use of protocols everywhere, right? It only mandates use of this lifecycle protocol. And you can also be quite careful, right? So you can also, shouldn't pass around the system map everywhere, right? So you should only pass around the dependencies that you really need. So let's do some little bit of summing up. Dependencies enclosure. We've seen quite a lot of ways to manage dependencies, and I haven't even talked about all of them. For instance, I left out mount. There's a lot of choice regarding what you want to make explicit or what things you want to leave more implicit in your code. We also have seen quite a variety regarding the time and place of dependency resolution. So from higher order function, right, where basically what you need is really constructed and resolved at the time where you really need it. We had the contrast with component here just recently, where everything is constructed at one single place and time, and it's available globally for the application. But we're lacking sort of like a controlled middle ground, right? For instance, things that you might have in a Java container, we can say, okay, I need a new state, a new connection whenever I have a new request or when I come to a new transaction boundary. And if you ask me, what I would suggest is that you keep it simple, right? So don't try to over-engineer it, right? Try to focus on the important things. So still prefer small functions, pure functions, and if there is one additional thing, try to reduce the dependency problems to specific pieces of code, which are especially intended to really be there for integrating things, right? So you can separate out the business stuff from your integration points. And that's also a great way to get rid of all these testing motivation for dependency injection, right? For the dependency shuffling around. And another point is that you don't always have to split out every cases, right? So all options, you don't have to make everything available and configurable, right? You should only split out the dependencies where you really think, okay, this could change. This is important that I will be able to change that in the future, right? And if you, for instance, have already two different implementations because, for instance, you're checking out whether you're going to use Mongo or whether you're going to use some other database, right? So that's a great indication that this might be a relevant point where you're going to split out the dependency. So, and that's everything that I wanted to show you. Thanks a lot for your attention.